Assalamualaikum and a very good evening. I bid to my supervisor, Ms. Suzana binti Harun, and my visiting lecturer, Dr. Muhammad Ar-Rashidi bin Abdul Manap. I am Nurani Saudi Mehdi Hussain with matric number 192394. I'm a final year student of Bachelor of Science in Chemistry with honour. Today, I would like to present all the experiences that I gained during my 4 months internship at Era Lab KT Sdn Bhd. Okay, so a little bit on company's background. Era Lab Sdn Bhd was established in 1995. The word Era Lab stands for Environmental Research and Analytical Laboratory. Era Lab is a private-owned business headed by Mrs. Noor Azimah Mustafa, which is a registered EIA consultant and also a chemist. Era Lab offered a full spectrum of professional services of environmental services, occupational safety and health, consulting, laboratory services, and site sampling to nationwide industrial, commercial, and also government clients across multiple markets. Okay, so the aim is to provide cost-effective and on-time solutions to today's environmental and occupational health challenges. Era Lab registered with Petronas and currently holds a total of 11 categories of Petronas licenses under the environmental, industrial hygiene, and occupational health-related fields. Besides, Era Lab also acquired SAM accreditation, MS ISO IEC 17025-2005 for laboratory services, and also it was certified for ISO 9001-2015, which is the latest version of ISO 9001, to demonstrate the ability to consistently provide products and services that meet customer and regulatory requirements. Okay, so let's proceed to the next part of my presentation, which is experience. The first analysis that I learned was chemical oxygen demand, APHA 5520C. The reagents needed are potassium dichromate digestion solution 0.0167 molar for high range COD and 0.00167 molar for low range COD. Sulfuric acid, sulfamic acid control sample which needed to be prepared freshly before analysis. For high range, we use 200 ppm potassium hydrogen phthalate or KHP. For lower range, we use 20 ppm KHP. Ferric indicator solution, standard ferrous ammonium solution 0.1 molar for high range COD and 0.01 molar for low range COD. The procedure is very simple. All the reagents were pipetted into culture tubes according to the table here. The blank and standard use was distilled water, QC sample use KHP, sample solution use water sample. The solutions were then digested at 150 degrees Celsius for 2 hours. After that, the solutions were then cooled and 2 drops of ferrous indicator solution was added into each tubes and proceeded with titration using FAS solution until the solution turns brown. So here's the calculation for this analysis. Okay, the next test I learned was oil and grease partition gravimetric analysis, APHA 5220B. The reagents needed are stearic acid 98% minimum purity, hexadecane 98% minimum purity, acetone residue less than 1 ppm, and hexane, 2-propanol, sodium sulfate and hydrous crystal, and also standard mixture. So this standard mixture was prepared by using hexadecane and stearic acid, which then diluted until murk using acetone in 100 ml volumetric flask, and the precipitate was dissolved. For QC sample, 2.5 ml of standard mixture that already been prepared before was added to 1 liter volumetric flask, and then it was diluted to murk with distilled water. Okay, for analysis method, the dry distilling flask were weighed and marked accordingly. 1 liter of sample was measured and transferred into 1 liter separating funnel. 40 ml of hexane was added and the funnel was shaken vigorously for 2 minutes. And then the lower layer was discarded into sample bottle here, and the upper layer was drained into distilling flask through filter funnel containing filter paper and 10 grams of sodium sulfate. If emulsion is formed, a few drops of 2-propanol needed to be added in order to obtain clear layer. And then the sample was then extracted twice more with 30 ml and hexane each. The flask was distilled in water bath at 85 degrees Celsius until dry and cooled in desiccator for at least 30 minutes. Okay, for calculation, the final weight minus initial weight times 1000 divided by the volume of sample used. Next, for tertiary method following preliminary distillation step, ammoniacal nitrogen, APHA 4500 and H3C, the reagents needed are boric buffer solution, 6N sodium hydroxide, 1N sulfuric acid, 0.02 N standard sulfuric acid titrant, indicating boric acid solution, mixed indicated solution, and stock ammonium chloride solution 1000 ppm, or called stock A. So to prepare stock A, 3.819 gram anhydrous ammonium chloride were dissolved in water and diluted to 1 liter. And 10 ml of stock A was pipetted into 100 ml volumetric flask and diluted to mud with this water to obtain 100 ppm ammonium chloride solution, or called stock B. To prepare a QC sample, 2.5 ml of stock B was pipetted into 50 ml volumetric flask and diluted to mud with distilled water. Okay, so the analysis method was quite simple as well. For the blank, we use 50 ml distilled water along with 9 drops of 6N sodium hydroxide and 2.5 ml boric buffer. For QC sample, we use 50 ml of QC sample prepared before, and for sample, we use 50 ml of water sample. And then the solution was distilled using this distillation unit, and the distillation product obtained with boric acid were then titrated using 0.02 N sulfuric acid titrate. So this is a calculation for this analysis. The next analysis that I learned was chromium hexavalent, HEC method 8023. This analysis used HEC DR6000 spectrophotometer here. So the reagents needed are 50 ppm hexavalent chromium standard solution and also chromaver 3 reagent powder pillow. The QC sample was prepared by using 5 ml of 50 ppm hexavalent chromium standard solution, was pipetted into 500 ml volumetric flask and diluted to mud using distilled water. For sample analysis, standard program 90 chromium hex on DR6000 spectrophotometer were started, and then 10 ml of prepared QC sample were filled into sample cell, and 1 chromaver 3 powder pillow were added into the sample cell and mixed. And then we need to start 5 ml reaction timer on DR6000 spectrophotometer, and then fill another sample cell with 10 ml of prepared QC sample as blank, clean and inserted blank sample cell into zero holder and press 0 to zero the instrument, clean and inserted QC sample cell into sample holder and read the instrument. So repeat the steps 1 to 7 for water sample. So the QC is 0.497, between 0.497 to 0.503 ppm. The next analysis was chloride mercury thiocyanate method, HEC 8113. This one also using the R6000 spectrophotometer. The reagents needed were 1000 ppm chloride standard solution, mercury thiocyanate solution, ferric iron solution. The QC sample was prepared using 1 ml of 1000 ppm chloride standard solution, which were pipetted in 200 ml volumetric flask and then diluted with distilled water. For sample analysis, you just started program 70 chloride on DR6000 spectrophotometer, fill a sample cell with 10 ml distilled water as blank, and then fill another sample cell with QC sample. 0.8 ml of mercury thiocyanate solution was added into each sample cell and swirl to mix. 0.4 ml of ferric ion solution was added to each sample cell and swirl to mix. 2-minute reaction timer was started. Clean and inserted blank sample cell into a sample holder and zero the instrument, and then cleaned and inserted QC sample cell into a sample holder and read the instrument. So these steps 1 until 8 was repeated for water sample. The QC needs to be between 9.5 to 10.5 ppm. The last one is phosphorus, method 8048. The reagents needed were 50 ppm phosphate standard solution and phosphor 3 phosphate reagent powder pillow. To prepare QC sample, 2 ml of 100 ppm phosphate standard solution was pipetted in 200 ml volumetric flask and then diluted to mark with distilled water. For sample analysis, I started program for 90P react PP on DR6000 spectrophotometer, and then filled a sample cell with 10 ml of prepared QC sample and added 1 phosphor 3 phosphate powder pillow and swirl to mix. And then put stopper on the sample cell and shaken vigorously for around 20 to 30 seconds and started 2-minute reaction timer. In the meantime, I filled another sample cell with 10 ml of prepared QC sample as blank, clean and inserted blank sample cell into a sample holder and zero the instrument. And then I clean and inserted QC sample cell into sample holder and read the instrument. So the steps 1 to 8 were repeated for water sample. The QC needs to be in between 0.98 to 1.02 ppm. So a total of 14 parameters I've learned for 6 weeks of working at Lab KT Sdn Bhd. Because from week 7 until week 11, I work from home due to EMCO in a few districts in Terengganu, followed by MCO 3.0 phase 1. Also, I got the chance to learn a few management jobs, such as organizing the data files of different types of analysis and how to use the photocopy machine to scan and photocopy forms. I think it is an eye-opener on how the real working situation goes, as well as a great opportunity in order to improve and apply my laboratory's working skills. So I think Lab KT Sdn Bhd did a very good job in providing experience for interns before stepping out to working life. Lab also has a very conducive surrounding and very helpful and dedicated staffs that assist each and every one of us to perform all the analysis accurately. However, I think maybe in the next time, Lab should emphasize more on the calculation of the results obtained for each analysis. That's all for me. Thank you so much for participating.